I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to talk about the mathematical formulation of transportation problem and its meaning, and various types of transportation problem, and what are the various methods that are available to find IBFS, that is initial basic feasible solution, and how to find initial basic feasible solution using northwest corner method. So these are the concepts which I am going to talk in this present lecture. And what is a transportation problem? Transportation problem is a special kind of linear programming problem where there will be various sources and destinations. So normally an organization may have different sources, different origins from which products are to be supplied to different destinations. Different units are to be from origin 1. The organization can supply certain number of units to destination 1, destination 2, 3 and 4. So such a kind of with certain constraints on demand and supply. So based upon the supply and demand constraints of sources and destination respectively, how many units are to be transported from different origins to different destinations so as to minimize the total transportation cost. So such a kind of problem is called transportation problem. So the basic aim of a transportation problem is to find the optimum number of units supplied from one source to another destination so as to minimize total transportation cost. So such a problem is transportation problem. So here see, this is called mathematical formulation, the tabular form of the transportation problem, and here in this matrix you can see C11, C32 and all. These are the costs of transportation of one unit from one origin to another destinations. For example, if we consider this C11, C11 denotes the cost of transportation of one good from origin 1 to destination 1, from this first source to first destination. If we consider this C23, C23 denotes the cost of transportation of one good from second source origin 2 to third destination. So this is how we can formulate initially the problem as transportation problem. So now the objective is to find the optimum number of units to be transported from one source to another destination so as to minimize the transportation cost. Right. Now coming to the next concept, types of transportation problem. So basically there are two types of transportation problems. So two kind of situations may exist. So the transportation problem may be balanced one, the transportation problem may be unbalanced. So whenever we are going to solve the transportation problem, the particular point is to be taken care that the transportation problem must be balanced one. So the first step while solving the transportation problem is to check whether the transportation problem is balanced or unbalanced. So how can we check whether the given transportation problem is balanced or not? If total demand is equal to total supply. If this total demand gets equal to total supply, then the transportation problem is said to be balanced transportation problem. If these total demand not equal to total supply, then it is called unbalanced transportation problem. So this is first we have to check whether the problem is balanced or not in this way using this criterion. And next, how to solve. So this is the best example for unbalanced transportation problem. If the transportation problem is balanced, that's okay, fine, we can proceed for solving the transportation problem to identify the optimum solution. But if the transportation problem is unbalanced, what is to be done? So if the problem is unbalanced, we have to convert that unbalanced transportation problem into balanced. See here, the total demand is 95 and the total supply is 117. So the problem here is unbalanced one. So straight away the problem should not be taken like this. So this unbalanced problem should be converted into balanced problem in this way. So here whichever is lesser, that row or column we have to add. Since here the total demand is less, so therefore add additional, how much demand is lesser? 22 units are lesser. Therefore add one column with all the costs as zeros, and the balance demand we have to add here, and this is how we can transform the unbalanced transportation problem into balanced problem. This 22 is, that is 117 minus 95 is going to be 22. So this is how we can transform unbalanced into balanced. So after transforming the unbalanced into balanced, next we can proceed as it is how we solve a balanced transportation problem. Likewise, we can proceed to find out the optimum solution. So, in the beginning, we have understood that transportation problem is a special kind of linear programming problem. So, in linear programming problem, we find initial basic feasible solution. Likewise, in transportation problem also, first we have to find IBFS, that is initial basic feasible solution. So, we have various methods to find initial basic feasible solution. Northwest corner method, least cost method, Vogels approximation method. So, these are the several methods which we have for finding initial basic feasible solution for the transportation problem. So, let us move on to the next method. First method, that is northwest corner method. Okay. So, this is the problem we are given. So, what is the first step? Check whether it is balanced or unbalanced. So, here total demand is equal to total supply. Therefore, the problem is balanced problem. So, that is the first step we have to observe. Now, we understood this problem is balanced one. Using northwest corner rule, how to find the initial basic feasible solution. So, see here we have the chart. So, this is northwest corner, right? So, this is going to be the northwest corner. So, let us move on to this northwest corner, and for this origin, what is the supply? 300, and for this destination, what is the demand? 250 units. So, whichever is lesser, that if demand is lesser, that many quantities are to be allocated to that particular origin destination combination, or if supply is less, that number of units are to be assigned or allocated. Okay. So, 250, 300, 250 is lesser, therefore assign 250 units to that particular cell, and all the 250 units are being transported, strike off. And here total from origin 1, the company can supply 300 units. But out of 300, already 250 units are being supplied to destination 1. And now origin 1 can supply only 50 units. So, 50 more units are left over with origin 1. Okay. That is 300 minus this 250, 50. Right. So, now the total requirement for destination 1 was fulfilled. Therefore, strike off the first column. So, first column we should not consider for the next process. Okay. And next, in the remaining matrix we have to consider. Again in the remaining matrix, so this is going to be the 1, 2. That is first row, second column. This 1, 2 cell 1, 2 is going to be the northwest corner. Okay. So, for this corner we have to make assignment or allocation. So, how many units are required, demanded for D2? It is 350. And for first row, how many units are left over for first origin? 50 are left over. So, 350, 50, whichever is lesser, that many units we have to allocate. So, 350, 50, 50 is lesser. Therefore, assign 50 units to that particular combination or cell. Okay. So, now 350 we have allocated, therefore, strike off 350. So, from origin 1, 300 units are to be supplied, 250 plus 50, 300 is over. Now, 0 units are left over for supply from origin 1. And for destination 1, 350 units are required. Already we have supplied 50 units to destination 2. So 350 minus 50, 300 more units are to be supplied to destination 2. 300 more units are required for destination 2. This is how we can understand the problem. Okay. So, and since all the units are supplied to from origin 1, now strike off this first row. This is the matrix we are left over with. We have deleted this first column and first row, and the matrix which is circled here represents the leftover matrix. Again in this one, this is going to be northwest corner. Now for this cell we have to make allocation. So here total units are to be supplied 400 and the demand for this cell is 300 more. So 300, 400, which is lesser 300. Therefore, assign 300. Strike off this 300. All units are supplied. Therefore, 0. And out of 400, 300 already supplied. So, 100 remains. 400 minus 300 is 100. So, 100 more units can be supplied from origin 2. Now, all the units demanded for D2, all the 350 were supplied. Therefore, strike off this column also. Next, this will be the leftover matrix, and for this again this is going to be the northwest corner. Okay, for this cell how we can make allocation, let us see. So, for this 100 are required, can be supplied, and 300 are demanded. So, which is lesser? 300, 100. 100 is lesser, therefore 100 to be assigned. Strike off this 100, 0. So, out of 400, 100 units are supplied, 300 will be left over, right? And this 100, all 400 units are supplied from origin to strike off second row. Now, this is the leftover matrix and this cell is going to be northwest corner. That is, cell 33 is going to be the northwest corner. So, here how many units are required? 300 are required, and how many units can be supplied? 500. So, whichever is lesser, that value we have to assign. So, 500, 300, 300 is lesser. So, therefore, assign 300 and 500 minus 300 is going to be 200. Strike of all 400, 300 plus 100, 400 units are supplied to destination 3, strike off that column also. Next, lastly, we are left over with only this cell 34 is left over. 200 units are to be supplied, are demanded, 200 are left over. So, allocate those 200, leftover 200 units to this cell. So, this is how we can transform, we can find out the optimum solution for transportation problem. Let me tell you how to understand this solution. Now, all the units or quantities demanded for all the destinations were supplied from different origins. Now, how can we understand this final stage optimum solution of the problem? Here, there is 250. It means that, so as to ultimately the objective of transportation problem is to minimize the total transportation cost. So, how the firm can minimize its transportation cost? If the firm supplies 250 units from origin 1 to D1 and 50 units from origin 1 to D2, 300 units from origin 2 to D2, 100 units from origin 2 to D3, 300 units from origin 3 to D3, 200 units from origin 3 to destination 4. If the firm transports the goods from different origin to different destinations in this number of quantities, the firm can minimize the total transportation cost, and the total minimum transportation cost is 4,400 according using northwest corner method. This is how we can find initial basic feasible solution. So, by the end of this lecture, we understood that what is transportation problem, what is the objective or purpose of using this transportation problem, how to formulate the transportation problem, that is mathematical formulation of the transportation problem, and how to check whether the transportation problem is balanced or unbalanced. If it is unbalanced, how to transform this unbalanced problem into balanced, and what are the various methods that are available for finding IBFS, that is Ogle's method, northwest corner method, least cost method are available. So, and along with this, lastly, we have understood how to find initial basic feasible solution using northwest corner method. Thank you.